Welcome to this introduction to R tutorial, which is part of the network analysis course at Insper. Here you will learn how to install R and how to install RStudio. Then we will introduce you to some useful R commands. We hope you'll find this useful. If you already have some knowledge about R, you might probably skip most of this lesson and go straight forward to the end, where we will use lesson 1 as an example. In order to install R in your computer, you first need to download the R installer from the R website, which is r-project.org. In this website, you can click on CRAN, then you can select a mirror from which you are going to download the R installer. In my case, I always select this one here, UFPR, but you can feel free to choose any mirror that you want. You should then click on the download link that fits your operational system. So if you have a Mac, you should click this Mac OS X, and then you can click here to download the installer and follow the instructions in order to install R in your computer. On the other hand, if you have Windows, you should click here, then you should click on Base, and then you should click here in order to download R for Windows. And as before, you should follow the instructions in order to have R installed in your computer. After having installed R in our computer, you can go to RStudio's website, which is rstudios.com, and it is here that you are going to download RStudio. RStudio is basically a platform integrated to R. It is more user-friendly than R, and it helps us code, plot stuff, so it is a very useful platform and that you are going to be using a lot. Okay, so you can go here in Products, then you can click on RStudio. Let's just wait it to the downloads. Then you can select the RStudio desktop version. Okay. Then you can click here to download RStudio desktop. As you can see, it is free, so you can click here. Then you have to choose your version. Once again, the free version is enough for our purposes. So you click here, download, and then here it should be the download link that fits your operational system. Okay, you can also scroll down a little bit, and then you have the downloads for all operational systems here. So if you have a Windows, you should choose this archive here. If you have a Mac, you should choose this archive here. Okay, then you can just, as before, you follow the instructions, and then you have RStudio actually installed in our computer. Okay, note that it is very important that you have R installed in your computer before you decide to install RStudio in your computer. After downloading and installing both R and RStudio, you can open RStudio and you should find a window that looks just like this. You have here three different panes. The first pane here is the console. This is the panel where you are going to write your code and where you are going to see the results of your inputs. You also have another pane here, which is the environment and history pane. When we create variables, functions, when we load databases into R, this is where they are going to appear. And then in history is where we can keep track of all line codes that we have written in the console. There is also this third pane here, which is the Files, Plots, Packages, Help, and Viewer pane. Right now, what's more important for us is the Plots pane and the Help pane. When we plot a graph, and we will get to that in a moment, this is where your graph will appear. And also, when you have a question, you can type some commands in the console, and then they are going to appear here in Help. Now that you have already been introduced to the different panels in R, let's start to write our code. First, note that we can start with some very basic math operations, such as 1 plus 2, and then we get 3, which is the usual result, right? We can also have like 10 plus 10, and then we get 20, right? Another math operation is the product, so we use this asterisk for products, and then we get 5 times 2, so we get 10. We could also have 5 divided by 2, and then we get 2.5. Note that R is going to follow the usual rules for math operations. So if you type 5 plus 1 divided by 2, you're going to get 5.5 because R is first going to divide 1 by 2 and only then it is going to sum it to 5. Okay, which is different from having, for example, 5 plus 1 divided by 2, which then we get 3 because 5 plus 1 is 6 and only then we divide it by 2 getting 3. Okay, we can also have powers, so 5 to the power of 2, that's 25. And if you want to go in the opposite direction, that is, if you want to take the square root of 25, you could type either 25 to the power of a half, and that's going to get us 5, or, which is more intuitive, you could have square root of 25, and then you get 5. Note that square root here, or actually the function sqrt, is going to compute the square root of the argument of the value that is inside the parentheses. So we get 5 here. Okay. There are some other simple functions, such as, for example, the sum function. So instead of typing 1 plus 2 at the very beginning, we could have typed in 1, comma 2 inside brackets of the sum function, and then we get 3. We could also have as many elements as we want. I mean, we can sum as many elements as we want, and then we get sum of 10 plus 10 plus 10, and then we'll get 30. And you could have, as I mentioned, all types of sum that you can possibly think of. So these are just some very basic math operations, but very useful ones. So we have these very basic math commands, but in practice we're not going to be using element by element sum or element by element product. We are usually going to be dealing with objects such as vectors and matrices. So now we will start to build these different types of objects. Okay? So let's start with vectors. We can build vector using the function or the command C, and here C stands for combine, so we'll be combining values into a vector. So for example, if I write C 1, 2, 4, and 6, I get this vector that's 1, 2, 4, 6. Okay. Let's suppose, for example, that I want this vector that goes from 1 to 5. Okay, so as you can see before, you just have to type C and then all elements from 1 to 5, but it's not very efficient, especially if you think that you have a very large vector. Instead, we could use the notation, for example, 1 to 5, okay, and then we use this column here, and we get the same vector as we had before. Obviously, this is more useful when you have something like 1 to 100, because then we get a very large vector, and it's a lot easier to write simply 1 to 100. Okay. We can also sum vectors as we had before, so those math operations that we had before, they also apply to vectors. For example, if I sum the vector 1, 2 plus the vector 2, 1, I get 3, 3, because we'll be summing element by element. So I'll be summing 1, the first element from the first vector, to 2, which is the first element from the second vector, and then I get 3, and then when I sum the 2 second elements, then we get the second 3 of our computations. We can also have the product. So let's suppose that we want to have the product of the same 2 vectors, and then we get 2 and 2. Okay, so note that this is not a matrix multiplication, but it's an element-wise multiplication. So first we multiply 1 by 2, then we get 2, and then we multiply 2 by 1, and we also get 2. Okay, it's probably easier not to write these vectors each time, okay, but instead we could save them into objects. Okay, so we could assign these values into objects, and we can do that using arrows in R. So let's suppose that I want to call this vector C12y. So this is what I'm going to write here. So I do y, an arrow, and then C12. Okay, and now you can see that this y has appeared here in the environment because we have created this variable. Okay, and then analogously we can create the object x, which is going to be C21. Okay, so now you can see that you also have x here, and then you can perform the same types of computations that we had before, but we don't have to write it again. So you can do y plus x, you get 3, 3, and also y times x, and then you get 2, 2. Okay, so this is especially useful when we have very large vectors and very large matrices, but you can manipulate these vectors, these objects, more easily. All right, so we're talking about vectors, so now let's talk about matrices. Okay, let me clean this before we continue so that we can see better what we're doing here. Okay, so before I construct a matrix, let me create a vector, and I'm going to call this vector vector, okay, which goes from 10 to 19. Okay, and you can see that this vector has been created here. If you want to see how it looks like, you can simply type in vector here, and then it is going to print the vector that we have just created. Okay, now let's create a matrix. In order to create a matrix, we need to use the function matrix in R. Okay, so it's another function. It is similar to the sum function that we have previously seen, but it's going to have more arguments and more different arguments. Okay, so as you can see here, there's this yellow box that appeared here in our studio. It is telling us the arguments that the function accepts. So let's start with the data. So we want to fill in this matrix with the data that is in the vector. So our data is going to be vector. Okay, our number of rows is going to be 2, and then our number of columns is going to be 5. Okay, and then we get this matrix here. Okay, so you can see that R has filled in this matrix with the elements from the vector we have just created, and it fills them by columns. So it goes 10, 11, 12, 13, 14, 15, and so on and so forth. Okay, if you have any questions about how this function matrix works, you can type in ?matrix, and then here you can see that the help pane will pop up, sort of, and then you get the explanation for how to use the function matrix. Okay, so you can see that this function matrix creates a matrix from the given set of values. In our case, the given set of values is the vector called vector. Okay, and then you have here how you can use the matrix. Okay, so as we show, we have added the data, we have selected the number of rows and the number of columns, and we have this other element here which is by row, and by default it is set to equal false. So it means that R is not filling in the matrix by rows. Instead, it is filling the matrix by columns. So let's suppose that we want to fill it in by rows. Okay, so here in this panel we can just change it, and we can add a new argument that's going to be by row, and then it is going to be true. Okay, and you can see that now it is different. So we have 10, 11, 12 here, and then 15, 16, 17. So you can see that it has first filled in this line and then this line. Okay, so it is different from what we had previously. Okay, so now let's save this matrix in an element called M1, because I think this is going to be useful for us right now. So let's do this here. So I'm going to call this M1. Okay, and now we have this matrix M1 saved here. You can type M1, and then you can see that we get our first matrix here. Okay, so now let's suppose that I just want to work with in a specific part of this matrix. Okay, so we need to subset this matrix. Okay, so for example, let's suppose that I just want the first line of this matrix. So what I can do here is that I can type M1, then between these square brackets I write 1, comma, then a blank space. Okay, you can see that this is very similar to this sort of indicator that we have here. So when we type M1 1, comma 0, we're only getting this line here. Okay, so this one here stands for line, so this first position is the line or the row of the matrix, and then the second position here is the column position. Okay, so by analogy we could also have M1, and then if I just want the first column, I just write this, and then we get 10 and 15, which is the first column that we have here. We can also manipulate it in other ways. Let's suppose that I want to select in a specific element, that I want the element 2, 3, Okay, then I get 17, so second line, third column. I could also select more elements here. For example, I want in the first line all elements from columns 2 to 5. Then I get 11, 12, 13, and 14, which is 11, 12, 13, and 14 that we have right here. Okay, so this is the one way that you can subset this matrix. We'll get to a few different ones in a moment. But as you can see, this is a very, very simple matrix. Even the vector that we have previously seen is very simple. So now let's work with a more complete database. Okay, let me clean this up here again. And then we can use a database called empty cars. It is a database that is loaded in R. So it comes with R, okay, and you can, people usually use this matrix when they are learning R, okay. So you can see here that you have lots of different car models. You have how many miles per gallon these cars make. You also have how many horsepowers and cylinders and the weight of these cars. So you have all these different variables associated with each one of the car models. Okay, so it's a very more, this matrix is a lot more complete than the ones that we were working with before. Okay, but if I just type in empty cars, I cannot use this in my analysis. Okay, so we still have to load this matrix into R. Okay, you can see here that this database, this empty cars, is not in the environment, so I cannot work with it. Instead, what I can do here is that I can download this using the function data, and then I write empty cars. Okay, and now you can see that empty cars is here, so now I can use this and I can manipulate this. Okay, suppose that I want to have another look at this matrix empty cars, so I can type in view, VE with the capital V, empty cars, and then there pops up a new window here, which is the which shows us our data. Okay, there's another way where you can, suppose you minimize this and you had only this. If you want to view this, you can just click here where you have this data, and then this is also going to pop up here. Okay, so it's probably easier just clicking, right? So this is our matrix. It has lots of variables. It's very difficult probably to evaluate all of these variables at the same time. So let's focus now on 3 different variables. So miles per gallon, horsepower, and weight. So miles per gallon, horsepower, and weight. Okay, so how do we do that? So we're going to select only these columns from this matrix. So you can follow the idea that we have previously seen. So I just type in empty cars. Sorry about that. So empty cars, and then we're going to select the columns. Okay, note that we need to use a vector because we're not selecting one vector or a sequence, not selecting one column or a sequence of columns, but it's like different columns, right? So it's a vector of columns that we are selecting, and then I can write 1, 4, and 6, which is the position of these vectors, of these columns, and then we can see that we get only miles per gallon, horsepower, and weight. Okay, sometimes it's difficult to know the exact position, especially if it's a very large matrix, so you could simply type in the name of these columns. Okay, so you could do in this vector, you can have, for example, miles per gallon, and then you can have weight, and which one was the third one? Horsepower. Okay, and then you have this here. Okay, and you can see that they are going to appear in the order that you have selected them. So even though in the original table you had horsepowers before weight, since I have selected weight before horsepower, this is how it's going to appear in this new matrix. Okay, now let's save this new matrix in a new object, which I'm going to call simply cars. Okay, so you can see here that cars is this new one, or you can just come here and click, and then you get this new matrix here. Okay, so now let's suppose that we want to compute some statistics about this car. For example, let's suppose that I want to find the average miles per gallon, millage per gallon that each car makes, that not that each car makes, but that all of these cars make, right? So what we can do here is that we can compute the mean, okay, of the column miles per gallon. Okay, and then we get that this is 20.0. Okay, there's an easier way. You can type in call means of cars, and then you get the means of all columns from our data set, which is called cars. Okay, there's another function, an analogous one, which is called row means of cars. Okay, and you can also compute this, but in our case, this is not, it does not make sense, right? Because take, for example, here Mazda RX-4. If you look here, you are summing up and taking the average across miles per gallon, weight, and horsepower. So they have different units of measure, and it makes no sense. This value here, what is this 44.5 here? So, but yes, but this could be a very useful function depending on the type of question you want to answer or on the structure of the database that you have. Okay. You can also plot something if you want. So let's suppose, look at miles per gallon and weight. We kind of expect that there will be a negative relation between the weight of the car and the miles per gallon, the millage per gallon of the car. So let's try to put it in a plot to see how it looks like, right? So you can use the function plot, okay? And then you need, for the x-axis, I'm going to select miles per gallon. So this is going to be cars miles per gallon, and then here we get the weight of the car. Okay, and you can see here the plot, so it appears in the same place where we had our help before, but the help thing is still here with our last help question, which was matrices. Okay, but this is the plot, so you have cars here, and you have miles per gallon here, millage per gallon here, and the weight of the car here. So as we expected, this downward sloping curve. So the lighter the car, the more miles per gallon it makes. Okay, as you can see here, this is not very simple. You can write it differently. Okay, so instead of writing cars, then inside the brackets, comma, miles per gallon, you could simply type in cars $mark miles per gallon, and then you get the vector of all the elements here. Okay, or you can write cars weight, and this is what we get. So these are all the weights of all cars, and you can see here that if we plot simply cars miles per gallon and cars weight, we get the exact same plot as we probably expected, right? The only difference here is the name of the two axes, because they are the names of the thing that we input here. Okay, this function plot, it has a lot more functionalities, so you could basically change everything that you have in the graph. You can change the names of the axes, you can change the type of the graph, the colors, and lots of stuff. But for our objectives here, which is show you how this functions and this plot thing works, I think this is okay. During our course, you have lots of opportunities to create some very nice and very interesting graphs. Okay, so this is the plot function. Okay, it's a very sort of raw graph, so you can see here that the way we did it here, it's very simple. Okay, so let's suppose I want to build something that's more visually appealing. Okay, so what we can do here is that we can install a package that's destined for this, that was made for this. Okay, and what is a package? A package is basically a collection of functions and data sets in R. Okay, so I suppose you want to answer a very specific type of question of a very specific type of problem. It's very likely that there's already some R package ready for you. Okay, so let me clean this window here once. I'm going to keep the data set here. You can see that the plot is still here. And let's try to install a different package that's going to help us create different types of plots. Okay, one of these packages is the well-known ggplot2. So we can type in this install packages function and then ggplot2 2, okay, and then let's install this. Okay, so I wrote the function, right? You can see that you have, it's basically probably easier if I had just clicked enter before, and then it's ggplot2. So I already have this, so it's actually going to install again this package, okay? But now it is installing this package, so I don't have to do anything now, just wait for a few seconds, okay? And that's it. So now we have downloaded ggplot2, okay? And now let's use another function that is inside this ggplot2 in order to plot a different graph. And this function is the function ggplot. So this is also going to plot something. And this function has a different syntax. Okay, so you don't have to worry about it now. I just want to show you why packages are useful. Okay, so in this case here, oh yeah, so before I do this, and that's a very big mistake, we should, so I have downloaded this, but I have not installed ggplot, I have not loaded ggplot2 into R. Okay, so think about the empty cars database that we had before. So it is in R, but we have to load it before we use it. Okay, so it's the same thing about now. So I have this package ggplot2. So now let's load it into R. Then I use the function library and then ggplot2. Okay, and now we can use this. Okay, so it looks like nothing has changed, but actually all the functionalities associated with the package ggplot2 are now available for us. Okay, so now let's use the function ggplot. As I mentioned, it has a different syntax, as I have already mentioned too. So in this case, what we should have is that we're going to use the database cars, and then istatics, which is basically like the axis of the graph. In this case, we are going to have miles per gallon and weight, and then we add the type of graph that we want, which in our case is geom point. Okay, so this is just like a scatter plot, and then we get this new plot. It is very similar to the previous one in the sense that the data is the same, but we could argue that it's more visually appealing. Okay, so this is why people usually use this ggplot2 package. Okay, so if I had not installed it, I wouldn't have this new function here, ggplot2, okay, and I wouldn't be able to have this type of graph. Okay, so now we have already introduced you to many of the functions that and of the comments that we are going to use in the first session of the network analysis course, and this is what we are going to be doing in this next section. So we are going to open the R Markdown archive for the first session, for the network literacy session, and then we are going to build an R script, and we'll get to that in a moment, with the comments for our first session. Okay, so now that you have already been introduced to some initial R commands, let's use the R Markdown for the first session in our network literacy course to practice a little bit. Okay, so in the Dropbox for this course, you can find a document like this one. So this is what we call an R Markdown. And you can see here that it explains how you can run the code that implements some of the concepts and some of the analysis that were discussed in class. Okay, so in this case here, there's some introduction, but I think we have already extensively discussed some basics about R. Okay, and the idea here is that in order to keep track of what we are doing, you should always write what we called a script. Okay, so if you go here in R, previously we were writing our code here in the console, but you could see that we were losing the lines that we were writing. Okay, so what we usually do is that we keep it all in one document, and then we run this document or the lines of this document. So if you go here to this part, you can start a new script, so which is going to open right here in this panel. Okay, so this is where we are going to write our line code, and then we are going to run. Okay, so just to give you another example, so if we do the usual 1 plus 2 here, and then we click run, this is going to run here in the console with the answer. But you can see that this data is all stored here, and then you can save this into a document, and then you can open this later. So it's very useful to keep track of what we're doing. Okay, so in our case, let's just delete this. Okay, and let's see what the R markdown is telling us to do. So for this first session here, we need to install and load the package iGraph, which contains some useful network analysis tools. As we have seen, we can run the function install.packages by typing install.packages iGraph. Try it in your console. You can try it in your script. Okay, and then let's do this, and then so you just run. Okay, you can just press enter. So that's it. So this package iGraph has been installed. Okay, now let's load it into R. Okay, so let's copy this here. Okay, so that's it. So we have already loaded the package into R. It's very fast, actually. Okay, and first we're going to use this data set now called the adjacency matrix CSV. It can also be found in the Dropbox folder for this course, and we always recommend that you download it to your computer and save it in a folder with the other archives for this course. I have saved it in the desktop for this course, but you can save it in any place you find suitable. Okay, so let's use, in order to load this function, this file into R, the function read.csv. So this is a function to load comma-separated value files into R. Okay, and we're also going to store it into a variable called data. Okay, so let's copy this line here. Okay, then let's do this, and then we run. Okay, and that's it. Yeah, as you can see here, that in the environment we have this new data set called data. We can click it. Okay, if you want to have a scene this, so you have all these people here, and you have the ties between them. So you think about the adjacency matrix. So the persons here, they are the vertices, and then the zeros and 1 here are indicating if there's an edge connecting these two people. Okay, so if we go back here, we have already loaded the data. You can also have another option here where you can type file.choose, and then instead of writing the code, the path will sort of pop up. Okay, so let's do this here. Okay, so I'm going to do this here. So file.choose. Okay. Oh yes, sorry. Not choose. Okay, and you can see that something like this would open up in your computer, and then you can just find the document that you want. Okay, but this is not what I did here. Okay, so now I have already looked at the data. So let's try to build a network. Okay, the problem with building this network, okay, is that R and this library iGraph does not see this as a network. It sees this as a table, as a matrix. Okay, so we need to coerce this data set into another type of object, which is in this case is a network object. Okay, in order to do that, we can use this function here called graph data frame. Okay, so let's use this, and then we're going to store this into an object called network. Okay, remember that the arrows here mean that we are storing this into a network. Okay, so let's run this. Okay, and now we have a network here. Okay, let's have a look at it by typing network. Okay, and so this is what we get. There's not much we can conclude from this. It looks very different from the table we had before. So for us, maybe the table is more useful, but actually when plotting and when making analysis for the package or using the package iGraph, it is probably better if we have this data set in this format here. Okay, so this is what we have there. So now let's plot this new object, this network object, so that we can see what we find here. So now let's plot this, then it's running, and this is what we get. Okay, so it's a very messy graph, especially because we have all these labels right here. Okay, so it's not helping us a lot to conclude anything. Okay, and as I mentioned before, the plot function has lots of arguments. Okay, so you can change the name of the variables, you can change colors, you can change the type of the graph. Okay, so this is what we are going to do right now. Okay, so let's change this a little bit. Okay, so let's copy that code I have over there, and then we are going to get, you can divide this into 2 lines. There's no problem about that. Okay, as long as you don't close the parentheses, R will just take this as being a single line code. And now let's run this, but I want to select 2 lines and then run. Okay, so now we find it's basically the same graph that we had before, the same plot, but it's a lot cleaner. Okay, so you can see that we have 2 different clusters here. Okay, and they're all like sort of connected here to this one person, here to this other person, but you can see that this graph is a lot cleaner than the previous one. And that's all because of the extra arguments that we have added. Okay, so we have changed it. So we have said, for example, here that we do not want the labels, so we said vertex label NA. We have probably decreased the vertex size and the edge arrow size. Okay, and then there's this layout here. Okay, probably if you like have any questions, if you have doubt, remember that you can always tell help. Okay, not help, but you can the question mark plot and find the arguments. Okay, the thing about this plot function is that it supports a lot of arguments of graphical parameters. Okay, as you can see here, there's 3 dots in the function. Okay, which is basically what we did here, and it will depend on the type of object that we have. So this is something that you should always Google to see how to plot networks, what people usually use, or you can look at examples from the internet. So you can take this one here as an example, for example. Okay, let's see what else we can do here. And then in the end here, we are just going to do this with the same thing that we have done, but with a new data set. So I'm going to load into the second data set here, which I'm going to call data 2. Then we can run. Okay, so now we have this data 2 data set here, which is another data set. Okay, you can look here. So this is what we have now. So just the number of 2 people and how they link to each other, sort of. Okay. Then we can transform this into a network object. Okay, and then if we have a look at this network object, network 2, it is going to look the way it looked before. So it looks very different from the table that we had with data 2. Okay, so this is what I did there, and then we can plot this. Okay, let's run this. Okay, and then we have this graph here. Since it's way smaller than the previous one, we already can see this here. Okay, so yeah, so that's it. Just as I mentioned, different types of table, different types of graphs of data will generate different types of plots, and you should manipulate it accordingly. So take, for example, this data the first data set that we looked at. So this was the adjacency matrix we were discussing, while the data 2 was a edge matrix. Okay, so for those two elements here, we're going to have an edge linking those two vertices here. Okay, and so we have this graph here as a result. Okay, you can play with this data set if you want. You can try different layout systems. You can try to change the vertex size to see if it changes something. Okay, for example, let's use this first one here, and let's keep everything like that, but let's leave the vertex label here and see what happens. So let me select these two lines here, and then I'm going to run this. So yes, you can see now that you have the labels, it does not look good. Okay, so let's go back to not having the labels, but instead of having this edge arrow size very small here, let's increase it to 0.1, so it's 5 times larger, and then we can run this. So yes, it has increased, but the previous one was very small, so it does not make that much difference. Let's see if we increase it even more, what we get. So yeah, so now, oh yeah, so this is this thing here is changing. See, there's the arrow, okay, not the edges. Okay, but it's larger now. So you can see that you can play with it and see what you believe is better. Okay, so that was it for today. Thank you a lot, and I hope you learned something with this very short introduction to R. Thank you.